So here we go. The formula for sample mean is given as follows. So sample mean is the arithmetic mean of a set of sample data given by x bar equals, and then we're just adding up all of those things to, and this x sub n just means the nth thing. So if there were 5 things, this is like the first one, the second one, the third one, the fourth one, the fifth one. And so that n just says is for however many there are. And then you're going to divide by how many things there are. This is no different than any average you've ever taken before, right? You add them up and divide by how many there are. So don't get too lost in the notation. That's just what you always known to be the average. Okay? And so we can make this shorter by using our summation symbol. So it's the sum of all the x's over how many there are. And I think we already talked about this before in a different section, but remember x sub I just means whatever data value, x sub 2 is the second data value, and n is just the sample size or the total number of data. So nothing too crazy there, just add things up and divide by how many there are like you've seen before. Anybody need more time there? If you do, it's fine, but stop me if you do. All right. So a couple new symbols here. You heard me read this one as x bar. Okay, x bar stands for the sample mean, and that's exactly how you read it. X bar. Everybody say x bar. Feels like a Monday morning. I know it's Tuesday morning. I'm going to remind you guys. And the other one is this Greek letter here, and that's the Greek letter mu. Everybody say mu.
Mu.
Bunch of cats in here. So, and that's population mean, okay? So the sample mean is like adding up and dividing by how many are in the sample. Population mean is adding up and dividing by how many are in the population. So it's the same process, it's just one's for the sample, one's for the population. And that's just how statisticians differentiate between.
So it's like the same thing, but it
It's-
means something different?
Well, it's the same thing, it's just are you looking at a sample and doing that mean, or are you looking at a larger population and doing that mean? But the process is identical. Because here's population mean. Notice the only difference in the formula is what? Looks oddly similar. Capital N. And so capital N just stands for the number of values in a population, whereas lowercase n was the number of values in sample size. So that's the only difference. It's the same thing. Add them up, divide by how many there are. Remember, sample is some small subset of the population. Population is the whole group that we care about. And so we're actually going to calculate the mean. Everybody got a calculator handy? Go ahead and grab that. You don't need it. Make sure you get in the habit of bringing a calculator to class, because you'll want to practice with one so that you're ready to use it on your test, and you will want to use it on your test. Test is going to be next week Thursday, so a week and 2 days. Next week Thursday. We'll review on Tuesday, and then take the test Thursday. All right. Anybody need more time here? All right. Rounding rule. When calculating the mean, round to one more decimal place than the largest number of decimal places given in the data. So if your data is like all things that are tenths place, then keep hundredths place. Okay? That way you're keeping one extra decimal past whatever your data says. That way you can be more exact. All right. Occasional exceptions to this rule can be made when the type of data lends itself more natural to a natural rounding scheme, like whenever we're dealing with dollars and cents. We're always going to keep 2 decimal places. Even if our data is in dollars and cents, we're not going to keep an extra decimal, because money, we don't keep more than 2 decimals. All right, so let's actually do an example now. Students were surveyed to find out the number of hours they sleep per night during the semester. Here's a sample of their self-reported responses. Calculate the mean. All right, so what am I going to do here?
Add them all up and give the value.
Add them all up and divide by 7, because there are 7 data values, right? So make sure you know how many there are. 1, 2, 3, 4, 5, 6, 7. So we're going to add those things up and divide by 7. Everybody get approximately 6.9? And this is just how you got there, right? You added them all up and divided by 7. So that's just kind of the formula showing how it works. But nothing too crazy. Stuff you've seen and done before. The level of difficulty is extremely low. Alright. Now, I'm also going to show you how to do it on your calculator. So, grab your calculator. Let's go to Stat Edit. Or to a new list and spreadsheet if you are on Inspire. Stat Edit and List 1, you can go to the top and hit highlight L1 and hit Clear Enter, and it'll clear out that first list for you. And then in that list, you're going to put your data. So go ahead and put 5, 6, 8, 10, 4, 6, 9. Everybody got that data in the list? So now what you can do is hit Stat again, but you're going to slide over to Calc. So you're going to hit the over arrow to get Calc highlighted. And then the first thing that you see is 1var stats, one variable statistics. Hit Enter, and it'll bring it down to the calculator screen, and then you can hit Enter again. And here are, for future reference, here's the directions that we just went through. Stat Edit, we'll put the values in L1, and got rid of our old data first. And then Stat Calcs, 1var stats, and hit Enter. And that took us to, so that's putting the data in, and then that took us to here. Everybody should be here now, right? Anybody not okay with getting there? All right, so then what's our mean? 6.9. How do you know? Because X bar is the symbol, right? That's what it means. Okay, that's our sample mean, and so we look at our decimals here, and all of our data were whole numbers, right? So because all of our data were whole numbers, we just round to the nearest decimal after that, so the nearest tens place. So 8.5 tells me that 8 becomes a 9, which is exactly what you got on your calculator when you were doing it, right? You know, when you add them up and divide by 7, you got this same long decimal, correct? Right? Yeah. So not so bad when you've got just a few numbers, but if you have a list of a whole bunch of numbers, this can be an easy way to get a lot of information about it. All right? And so that's just talking about what we talked about. There's the decimal, and we rounded to 6.9. Okay? And there, the note they make at the bottom is we're going to use this procedure a lot with 1var stats because it gives us a lot of information on that screen. All right? Example 2. Rutherford downloaded 5 new songs from Apple Music. He knows that on average the songs cost $1.23. If 4 of the songs cost $1.29 each, what was the price of the 5th song he downloaded? Okay? So it's that same idea of finding the mean, but this time they give us the mean and they want to know the 5th data value, right? So this kind of goes back to thinking about when we wrote out X bar equals the first X plus the second X plus the third X plus the fourth X plus the 5th X, and it kept going to however many there are over the number of things that there are. But we know in this case, how many songs did he download? 5. So right away I know I can stop at 5 on top here, and I know the bottom number is 5, right? N, 5. So I can fill in 5 is that N. Gabe, what's X bar? 123. How do you know?
It says that like if the average is 120.
Yeah, because X bar is the mean and they give us the average, right? Mean and average, okay? So yeah, you're absolutely right. Just want to make sure everybody knows why you're right. Okay? Everybody tracking so far? All right, Abigail, what should I put in here for these first 4 X's? Oh, you already added them together? I'll just write them individually first, but yes, you're correct. She's just added them up, but I want to write them out so we can see where they came from. So each of them costs $1.29, right? How about for that last fifth x? What do I write? What should I write for that last one? X, because that's the thing we don't know, right? Yeah. So now we just solve this problem, all right? Still 1.23 equals, and then Abby, you added those up, right? What'd you get? 5.16. Everyone in agreement with Abby? Everybody tracking to that? All right, now, Kate, just solving an equation, what should we do next? Yeah, multiply both sides times 5. So times 5 cancels those. Times 5 over here. Okay? 123 times 5. What are we getting? 615. So 615 equals 516 plus x. Ava, how do I finish that off then?
Subtract 559 from this side.
Yeah, 516, right?
Yeah, that's a good one.
Subtract 516 from both sides. Which means that x is how much? 99 cents? So that's how much the fifth song he downloaded must have cost. So it's still using that same equation, but now instead of solving for the mean, they give us the mean and all of the data except one, and we can figure it out from there. So that's a common style of question, where they give you all but one of the pieces of data, and you need to find what's the missing piece so that that's the average. And we'll talk about later on, it's helpful for calculating grades when you're trying to figure out what your final grade is going to be. All right? So those are all the steps that we just did. Anybody have any questions about those steps? Everybody okay to move on? Okay, slow me down if you need to. Next we're going to talk about the weighted mean. The weighted mean, okay? So the weighted mean is the mean of a data set in which each data value in the set does not hold the same relative importance, okay? An example would be, I could talk about your grades, right? A test is not worth the same as a homework assignment, right? And so those grades are weighted differently. So the formula for calculating a weighted mean is given by the sum of all of the x sub i's times the w sub i's. Well, what does that mean? Well, x sub I is the data value, and w sub I is the weight of that data value. So if tests are worth 40%, the test score times 0.4 to 40%, that weight. Okay? Divided by the sum of all the weights. And so you could either use 0.4 and 1 or 40 and 100. Either way, because of the division, it'll work out. So that's the difference with weighted averages, weighted means. Okay? You have to take it times the weights and then add them up. Everybody okay to move to the next slide? I didn't even put this in there. It's long and not all that interesting. I think I took it out of you guys' slideshow. All right, so now let's go ahead and do an example. There's going to be, I think, a couple parts to this. There's, part A and part B. So let's worry about part A first, calculating a weighted mean. The syllabus in Walter's U.S. History class states that the final grade is determined by tests, which are 40%, homework, which is 20%, quizzes, which are 10%, and the final exam, which is 30%. Walter wants to calculate his final grade in the course, below are his average grades in each category. Calculate Walter's final grade in U.S. History. And then those are the grades.